Hello everybody, once again on behalf of DM Tutorial, I welcome you to this edition of my series of tutorial videos. These videos are made as lucid and as succinct as possible with the objective of mitigating hardship of students who are facing problems in understanding critical subjects and topics. Today's topic is convexity of indifference curve. Basically, this video is based on answering two questions. Number one, why indifference curve is convex, and number two, why it cannot be concave. Okay, we will learn it through three diagrams actually. One is the convex indifference curve, number two, concave indifference curve, and number three is straight line indifference curve. Okay, let's see the indifference curve. Convexity of IC. We are drawing three indifference curves. This is convex. This is concave, and last one is a straight line. This is IC1, this is IC2, and this is IC3. On all the diagrams, we measure quantity of x on x-axis, quantity of x, and y-axis we measure quantity of y. Okay, now carefully watch three indifference curves. In convex one, the consumer is sliding down the indifference curve from P to Q to R and finally to S. So as he is going on purchasing one commodity X from X1 to X2 to X3 then to X4, he sacrifices Y. This is Y1, this is Y2, this is Y3, this is Y4. This is Y4. Okay. Now consider this concave indifference curve. Here the consumer is doing the same thing. He is increasing consumption of X by one additional unit. This is X1, this is X2, this is X3, this is X4. Say this is X5. Sorry. This is Y1, this is Y2, this is Y3, this is Y4, and this is Y5. Now in this straight line of indifference curve, same thing is being repeated. The consumer is going on consuming one additional unit of X by sacrificing some Y. So this is here, this is X1, X2, X3, X4. So it is Y1, Y2, Y3 and Y4. This is straight line. Straight line IC. So we have drawn three indifference curves. One is convex one, second is concave one, and the third is straight line word. Now let us see what difference they are making. In case of convex indifference curve, as the consumer goes on purchasing X by increasing it by one additional unit, he is sacrificing some Y. In the first instance, this is sacrifice of Y, that is delta Y, and this is his gain of X. So he is sacrificing this much Y to gain this much of X. In the second instance, that is at point R, he is sacrificing this much of Y. This is delta Y to gain same delta X. That means in convex indifference curve, delta Y by delta X is falling. And what is delta Y by delta X? It is nothing but marginal rate of substitution. That is the rate at which one commodity is substituted for another commodity. And what is happening in case of concave indifference curve? You see, this is sacrifice of Y, that is delta Y. This is gain of X, this is delta X. Say this is A, this is B, this is C, and this is D on IC2. So as the consumer slides down the IC2 from point A to B, this is A, this is B, C, D, and this one is E. A, B, C, D. Okay. As the consumer moves down IC2, he sacrifices this much of Y to gain this much of X. And then from B to C, he sacrifices this much of Y to gain this much of X. And then C to D, he sacrifices this much of Y and this much of X. So what difference we can see between this convex and concave indifference curve? That in this case, in case of concave indifference curve, delta Y by delta X is rising. Why it is rising? Because delta Y is gradually rising, delta X remaining same. That is why delta Y by delta X is rising. And here delta Y is falling down, whereas delta X remains constant. That's why delta Y by delta X is coming down. And now come to straight line indifference curve. Same thing is happening. The consumer is consuming this much of X by sacrificing this much of Y. Say this is R, this is point R, this is S, this is T, and this is U. So as the consumer moves down the indifference curve 3, IC3, he sacrifices this much of Y to gain this much of X. So this is delta Y and this is delta X. Again, as the consumer moves further down from S to T, he sacrifices this much of Y to gain this much of X. So here this is delta Y and this is delta X. So you can see here delta Y by delta X remains the same. Why? If we take these three individual triangles, from the law of geometry, we know these angles are same because these are corresponding angles. Now, what is the slope at this point? That is tan of this angle, that is perpendicular by base. Now perpendicular by base remains constant in this case because delta y is remaining constant. Delta y is remaining constant, delta x remaining fixed, and all the angles being equal, delta y by delta x remains constant. So in this case we see delta y by delta x is constant. So far so good. I take liberty to erase it. So in convex indifference curve, we see delta y by delta x is falling. In concave indifference curve, delta y by delta x is rising, and in straight line I see delta y by delta x is constant. Now we know the indifference curve analysis and establishment of consumer's equilibrium through IC technique. MRS of x for y goes down. That means marginal rate of substitution of x for y goes down. This is the basic principle on which IC is made, constructed upon. So this is the only possible shape of an indifference curve. This is the only possible shape of indifference curve because this indifference curve follows this law. Here delta y by delta x is rising, hence this IC is not following this law. Here delta y by delta x is constant, that means it is not changing, so it also does not follow the law. Hence only possible shape of IC is convex. Now I am erasing it. Start. Yeah, to take the analysis a bit further, I will draw two more indifference curves. One is horizontal straight line and another is vertical straight line. That means one is parallel to the x-axis and another is parallel to the y-axis. Okay, and let's see what will happen. On the x-axis we measure quantity of x, and on y-axis we measure quantity of y. Here quantity of x, here quantity of y. This is IC1 and this is IC2. So we have drawn two indifference curves, one horizontal straight line and another is vertical straight line. Now take this one. Say these are the 3 points on IC1, A, B and C. This is X1, this is X2, this is X3. So as the consumer moves along IC1, his consumption of X increases from OX1 to OX2. At point A, he was consuming OX1 of X and say this is L, OL of Y. As he moves along the IC1, he reaches point B, he is consuming OX2 of commodity X and same commodity OL of commodity Y. That means his consumption of X has increased from OX1 to OX2, but his consumption of Y has remained constant. And same thing has happened when he has moved from B to C. That means his consumption has increased from OX2 to OX3, but his consumption of Y has remained constant at OL. Now take this vertical one. This is horizontal. This one is horizontal. This is vertical. Now consider this vertical IC. Take 3 points P, Q, R. Here you see, say this is P, this is Q, this is R. As the consumer moves from P to R or from R to P, his consumption of X remains constant at, say, this is OX1. His consumption of X remains constant and at OX1. But his consumption of Y has been increasing. So the consumer cannot be indifferent between A, B and C. Similarly, the consumer cannot be indifferent between P, Q and R. In this case, you see, delta Y is equal to 0. Therefore, delta Y by delta X equals to 0. And here you see, delta X is 0. Therefore, delta Y by delta X is infinity. Here delta Y by delta X is 0 because delta Y is 0. Here delta Y by delta X is infinity as delta X is 0. But according to law of diminishing marginal rate of substitution, delta Y by delta X must fall so that the consumer remains on the same indifference curve. So we can further say that indifference curve cannot be either horizontal or vertical. So it cannot be concave, it cannot be horizontal, it cannot be vertical. So the only possible shape of indifference curve is convex. This is called convexity of IC. Okay, that is enough for today. I hope you understood and enjoyed this video. I would appreciate suggestions and queries from your end. Those are most valuable for us. Okay, thank you for watching this video. Goodbye.